In this video, we shall look at a few techniques associated with differentiation of logarithmic functions. We stress here the logarithmic functions that we shall deal with in this video are all of base e. But sometimes it can be written as ln. So these are natural logarithms. Let's first see how to differentiate the simplest of them all, natural log of x. So what is dy dx? From differentiation from first principles, we know dy dx is the limit of delta y over delta x as delta x tends to 0. So delta y is y plus delta y minus y, where y plus delta y in terms of x is natural log of x plus delta x, and y is quite simply natural log of x. So using the rule of combining the two natural logarithms, it simply becomes x plus delta x over x, which is natural log of 1 plus delta x over x. Now let's divide both sides by delta x, so you will get delta y over delta x equals 1 over delta x natural log of 1 plus delta x over x. Now if you let delta x to go to 0 in the above ratio, then the above ratio will simply becomes 1 over delta x, and natural log of 1 plus a very small number is quite simply that small number. And as you can see, this delta x will cancel that delta x, and the answer is 1 over x. So now you have it. dy dx, according to this definition, when y is given by natural log of x, is quite simply 1 over x. Now this is a result that we shall be using over and over again in coming problems. So let's begin with more complicated expressions for logarithm. Let's say you have the following function. So how do you take the derivative with respect to x? Now we can use differentiating function of a function method. So by taking the quantity in the bracket to be, let's say, a function g, then dy dx is quite simply dy dg times dg dx. Now dy dg is simple because this function in terms of g is quite simply natural log of g. So dy dg is 1 over g, according to the result that we have just presented a few minutes ago. And dg dx, where g is given by 1 plus x squared, is 2x. And putting everything together, you have 2x, where g is given by 1 plus x squared. And that is the complete result for differentiating this entire function. What about the following function? Now note, the base is 2, not e. So we have to convert the base to e. How do we do that? According to some laws of logarithm, it is quite simply log of ex over log of e2. So that's how you change a log of any base, for example 2 in this case, to log with base e, or natural log. So we can write the above as quite simply natural log of x over natural log of 2. So dy dx can be computed readily. Note that the denominator, natural log of 2, is just a constant. You can take that out. And then natural log of x is quite simply 1 over x when you take the derivative with respect to x. So the final answer is 1 over x natural log of 2. What about the following function? Y is natural log of x. So let's first assume that natural log of x inside the bracket as a function. Let's call that function f. So again, it's like differentiating a function of a function. So dy dx can be written as dy df df dx. Now what is dy df? It's 1 over f. Because this is, in terms of f, it's quite simply natural log of f. And df dx is 1 over x. Now putting everything together, since what we know what f is just natural log of x, the final answer is quite simply that, and that solves the problem. What about this function? The same technique holds. Let's assume that sine x is g, so your y is natural log of g. So dy dx is dy dg times dg dx. dy dg is 1 over g. dg dx, that is what is the result of differentiating sine x with respect to x? It's quite simply cosine of x. So substituting g, you get cosine x over sine x, or cotangent of x. And that's the answer for this problem. Let's change the order of the operation. So now you have sine natural log of x. The same thing, let's assume that as f, so your y simply becomes sine of f, where f is a function of x. So dy dx is dy df times df dx. dy df is cosine of f, and df dx is 1 over x, because when you take derivative of natural log of x with respect to x, we know the answer is 1 over x. Putting everything together, you have 1 over x. Cosine of f is cosine of natural log of x. And that is the answer. Let's look at this problem. Now first, we understand that square root is power half. So let's write that first. 1 plus x over 1 minus x to the power half. Note, this half can be taken down in front of the natural log, which will give us half natural log 1 plus x over 1 minus x, which can further be broken up into two natural logarithms. The first one is natural log of 1 plus x minus natural log of 1 minus x. Let's do one by one. So there are two terms right there. Let's differentiate natural log of 1 plus x with respect to x. Now this you can do the same way. If you take 1 plus x as g, then d over dx natural log of 1 plus x is d natural log of 1 plus x over dg times dg over dx. Note that log of 1 plus x is quite simply log of g, and that is simply 1 over g. dg dx, where g is 1 plus x, is 1. So the answer is 1 over 1 plus x for the first term. So let's write that in blue up here. The result of differentiating the first term is 1 over 1 plus x. Now let's do the second. The second term is natural log of 1 minus x, right there. So let's assume that 1 minus x is a function f. So natural log of 1 minus x is natural log of f. So d over dx of a natural log of 1 minus x can be written as d over df, the natural log of f, times df dx. So d natural log of f df is 1 over f. df dx is minus 1, because f is 1 minus x. So putting everything together, you get minus 1 over f is 1 minus x. And that is the result of differentiating term number 2, minus 1 over 1 minus x. So that means combining both the terms, don't forget the factor half in front, so half, bracket. So the result of the first differentiation is 1 over 1 plus x. The result of the second differentiation is minus 1 over 1 minus x. But note there is a minus there. So this minus and that minus will give you a plus. 1 over 1 minus x. So combining the denominator, you get 1 minus x squared. The numerator is 1 minus x plus 1 plus x. Note that this minus x cancel that x, and you get 1 plus 1 is 2. 2 over 2, 1 minus x squared. So the 2 goes away to cancel each other, and your final answer is 1 over 1 minus x squared. And that's the final answer for differentiating this function with respect to x. So let's look at this function, and let's try to differentiate this function with respect to x. Let's first try to expand this natural log into 2. Now because it involves ratio, so it can be expressed as difference of 2 natural logs, like that. Now you see there are 2 terms. This is term 1 and that is term 2. So let's look at term 1. Let's try to differentiate term 1. Let's call the quantity in the bracket g. So d over dx, natural log of 1 plus x squared, is d over dg, natural log of g, times dg dx. So d natural log of g dg is 1 over g. dg dx, where g is given by this entire term, the 3 terms in the bracket, is quite simply 1 plus 2x. So putting everything together, you have 2x plus 1 over g, where g is 1 plus x squared. So that is the result of differentiating the first term with respect to x. So we have written here the result of differentiating term number 1. Let's do term number 2. So for term number 2, d over dx of natural log of 1 minus x plus x squared equals, let's call this term in the bracket for the term number 2 as f. Then this derivative is d over df, natural log of f, df dx. And we know what d natural log of f df is 1 over f. df dx is minus 1 plus 2x. That's what you get by differentiating this f with respect to x. Putting back the f, you get 2x minus 1 over 1 minus x plus x squared. And that's the result of differentiation of term number 2. So let's write it over here. That means dy dx is a sum of these 2 terms. So the first term is 2x plus 1 over 1 plus x squared. Don't forget this minus. So this minus is there, minus the second result, which is 2x minus 1 over 1 minus x plus x squared. With a little bit of algebra, this can be simplified to the following. 2 times 1 minus x squared over 1 plus x squared plus x to the power 4. And this is the final answer. of differentiating this y with respect to x. Thanks for watching.